Hey dudes, it's conferences. A little downtime, so I'm making a video. We are checking out 3-3 complement of a set. I'd like to put that at the top of your notes. You're going to follow along with this just as if I was there in class with you. Sorry, I can't be here in class with you. And also try this warm-up with me. I think you should pause me and try it on your own, and then unpause me and I'll show you how to do it. But try it on your own so you make those connections. We want an equation for a line that's parallel to this one and goes through this point, x and y. Pause me and try it. Ah, man, that again? I don't remember how to do that. Pause me. Okay, so this line looks like this. It starts at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Starts there, and it has a slope at -2, which -2 over 1. So it rises -2, 1, 2, and runs 1, so something like that. Or you could think about it going backwards 1 and up 2. Either way, you're on this line. And this point for -3, 1, 2, 3, 4, -1, 2, 3, this point is nowhere near that line. And I really want something with the same slope but goes through that point. Right? I want that one. So since it's parallel, I want to use the same slope. Right? This has the same slope as that. So I know that my new equation is going to look like y equals -2x plus c. And maybe if I continued this up, I could see that, oh, maybe it hits somewhere around there. But like I'm drawing with a mouse, man. Like it can't be that accurate. So I'm guessing around 1, 2, 3, 4. But I don't know for sure, so I'm going to try it out by putting this x and y point that I know exists. Maybe let's do it in a different color, green. X and y, that's right here. I know that point exists on the line. So I know if I put this x in here, if I put in 4 into this x, I have to get out this y value. I should get out -3. I have to. So you say I should get out -3. When into the equation I put a 4, multiply it by our slope of -2. The only thing we don't know is c, which is this intercept. So this becomes -8 plus c. Here's -3. We get rid of we isolate the c value by undoing -8. So we'd add 8 to this side. We'd add 8 to this side. Those cancel out. You get c is equal to about 5. So I was off, right? Surprise, surprise, drawing with the mouse. So in the end, we want to write the equation. Don't be a chump and just leave it like that. So this becomes y equals the slope that we want, parallel, so same slope as this original, -2x, and this is the y value, or the y-intercept, plus 5. Cool? Done. All right. Complement of a set. I will kind of walk you through this. I'd like you to pause me along the way and take notes. Maybe you want to copy this exactly. Maybe you want to just kind of interpret what I'm saying and put it into your notes. Either way, we're going to do a little bit of notes. We'll do a problem, and then you're off to try some practice problems on your own. All right. So a universal set is like all of the all the numbers that we're interested. So here's an example, like this is our universal set is all single-digit positive whole numbers. So 1, 2, 3, 9. No 10 because it's not single. No -5 because it's a positive. We need positive. So that's our universal set. So this is everything we wanted to play with. Those are all the numbers we get to play with. Maybe your universal set is all the numbers on a die. Right? And so like your universal set would be a 1, a 2, a 3, a 4, a 5, and a 6. Right? So your universal set would look like 1, 2, 3, 4, 5, 6. These little script brackets. Right? That's your universal set. It all depends on what situation you're talking about. The universal set could be the ages of students at ISL high school. And so the range would be, I don't know, 13, 14, 15, 16, 17, 18, 19. Maybe there's somebody who's flunked a ton of grades and they're like 22, and I don't know. And so this would be the universal set of the ages of students at the high school. Oh, and maybe there's like one really smart, like, fourth grader who's like 7, who's been promoted because he can do calculus already. I don't know, just making stuff up. To give you an idea of the universal set is everybody we want to include, all the numbers we want to include as we consider different sets. Okay, so a universal set we represent with a big U for universal. So the universal set, if we're like, I only want to talk about 2-digit positive whole numbers, we'd start at 10, 11, 12, but there's a bunch of them. We don't have to necessarily write them all out, and that's what this ... is about. This thing is called an ellipsis, and 3 is the approved number of dots. I think they have 4 here, which I don't like. But we don't go into 100 because it's no longer 2-digit. We don't go into 9 because it's no longer 2-digit. We don't say negative 64 because it's no longer positive. We don't say 10.7 because it's no longer whole. So this is the universal set that we want to work with, and then we go do other things. Cool? Put any of that into your notes that you need. All right. The complement of the set. Complement? I don't give compliments. If a set is A, like if our set is A, the complement of the set, we use this. It's called A prime, this little apostrophe. And A prime is the complement. The complement is everything that's not in A. So it's all the sets in the group that in the universal set. It's in the total group that we're interested in that are not in A. So, for example, if our universal set is the single-digit whole number positives, this is our universal set. And somebody says, "Hey, let's let a subset of that be A. Let's let A be like the odd numbers." So here's A. The odd numbers are 1, 3, 5, 7, 9. They're all part of the universal set. Therefore, the complement of A is everything that's not A, but is in the universal set. So we said, I want not A, so I don't want 1, I don't want 3, I don't want 5, I don't want 7, I don't want 9, because those are all part of A. I want the complement, which means I want not A. That's why I cross those off. And what's left is 2, 4, 6, and 8, right? So I want basically not the odds. So therefore you get the evens. Surprise, surprise, right? Notice that in this group, we don't have like 1.7. 1.7 doesn't show up here. Although it's not in A, we don't use 1.7 because 1.7 isn't in the universal set because it's not a whole number, right? So the complement, A prime, is everything that's not A but is still in the universal set. Yeah, I guess it should be in green. D. Cool. Great. Okay. So you could say this is like Q and Q prime are complements in the universal set R. So R is all real numbers. It means any number you can possibly think of is made up of Q, which is quotients, can be written as quotients, like a fraction, and also the stuff that can't be written as fractions. And you add those up and you'd get everything. So a couple little interesting pieces is that if you have the intersection of A and A naught, this is intersection. I think we've talked about that. It's what they have in common. So what's in A and also not in A, that nothing is there, is nothing. Right? What's in here and also in here? Where's the overlap? Nothing. Nothing. And we don't write nothing, we write empty set. We write this, the 0 with a seatbelt, like that. Cool? That's what that's about. This piece is if you add up everything in A and everything that's not in A. So this is, I want things that are A and also or things that are not in A, right? I want both. You get everything. If you say, hey, tell me all about, I want a set that's all of this and also all of this, you get that universal set back. Makes sense. And also lastly, they said if this n means how many numbers are in there. So if you look at how many numbers are in A and how many numbers are not in A, so there's what, 5 numbers here. So this would be 5, the number of terms in A. How many terms in not A? 4. If you add those up, you should get the same number of terms as in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Surprise, surprise. Add them up, you get 9. Cool. Okay, so we're going to try a practice problem, and then we out of here. Get your head out of the way, Gorkiewicz. Just stand up. Sit over here. I can still see you. I can still see you. Okay, so here's our universal set. Blah. Here's A and here's B. Okay. They want to find everything that's in A, or sorry, not in A, everything that's not in B, etc., etc. I think you should pause me and try these yourself, and then unpause me and see if the walkthrough is the same. Try this. This is your time to like practice it out. Cool. I'm gonna go get some coffee. Where'd your teacher go? Okay. Got some coffee. Let's roll. Here's A prime. So I want everything that's not in A. So A is -2, 0, 2, 3. So I want not that. So I want not 2, not 0, not -2, not 0, not 2, and not 3. I want everything that's not in here. And so what should be left over is -3, 1, and 1. Lo and behold, -3, 1, and 1. Cool? Things that are not in A. You can play the same game with not B. If you got that wrong, try not B yourself. Pause me. Okay, so I want everything not B. So it's everything in the universal set. It's everything in like the group of numbers that we're playing with, except what's in B. So I want not a -3. I want not a -2. I want not a 1 and not a 3. So I want -1, 0, and 2. Does that work? -0, 1, -0, -1, 0, and 2. Works. Great. We want for number 3, we want A, the intersection of A and B. It means I want the overlap. I want what they have in common. So let's see what they have in common. Hey, look, they both have a -2 in common, and they both have a 3 in common, and that's it. So -2 and 3. Cool. For number 4, I want the union. Means I want A and also B. Right? I want everything in A and everything in B. So it's sort of like saying I want the students that are in art and also in biology. And I want them in my class because I need to talk to them about a project or whatever. Everybody in art comes and everybody in biology comes, but some people are both in art and biology. They don't come to the meeting twice, they just show up once, right? So we don't write 3 and -2 twice, we just write everything that's in A and also everything that's in B. So here's -3, check. Here's -2, check. I know that it's twice, but why write -2 twice? There's 0, there's 1, there's 2, and there's 3. Double check, but don't write it twice. Right? So this is everybody that's in all of these. All my art students and all my bio students, and even the dudes that overlap. Or chicks? I don't know. Great. Okay. So we're looking at this one is the intersection of A and not B. Now what's kind of nice about that is we have already, if I clean this up a little bit, we have already found, we know A is right here. That's A. And we've already found not B. It's right here. Or more accurately, right here. Right? So in this, I want everything that is, I want the overlap of A and not B. So what they have in common. So what they have in common is a 0 and a 2. That's the overlap. So I think A and not B is the overlap of those two. So 0 and 2. So they put in, well, this is this, and this is this. And they just look what's in common. 0 and 2. Ta-da! Great. Okay, I like it. I like it. I like it. Let's try the next one. Let me clean up my scribble. Sorry about the scribble. Oh, this is the union of not A and also not B. So let's find not A and not B. And the union means I want both of them. I want the people that are not in art or not in bio. So I want the union of these two, which means I want the 3, I want the -1, but it doesn't. You don't have to write it down twice. It just happens to be in there twice. And I want the 1, and I want the 0, I want the 3. I want the union. I want all of these guys, but don't write down -1 more than once. So here's this part is -3, -1, 0. So that's this, and this is -1, 0, 2. This. And I want the union, which means I want all of it, and that's why you see the 3. You see the -1. You don't have to write it down twice. The 0, the 1, and the 2. Bing! Cool. This last one is I want the number of elements in the union of not A and not B. Well, we've already found not A and not B. This one's just asking for the n, which is the number of elements. So 1, 2, 3, 4, 5. So you'd say the number of not in the number of elements in the set of not A union not B is 5. There are 5 members in the set. Sweet. That's complements of a set. Cool. There are practice problems in your packet. They look like this. Zzz. You're doing the whole thing front and back. Check your answers. There's answers on the back. If you're done with those and comfortable, check your answers and be careful with them. If you're done and comfortable, go back to the 3-2 or the unit 3-1 and make sure you're okay with those. Cool. You got plenty to do. Get busy. Bye. Bye.